Good morning, everyone. I'm Piyush Kokate. I'm working as senior scientist at CSIR-NEERI Nagpur in Energy and Resource Management Division. So I'm going to cover the drone-assisted air quality monitoring and its role. So today I'm going to cover chapter 1, that is drone and air quality monitoring, and why air quality monitoring is required using drone-based technologies, and importance of AQ. So as we are aware everywhere that in especially air pollutants is a major leading risk factor in India, and it is considered as one of the very important risk factor in India compared to the deaths because of the different diseases, and at global level also uh, the deaths due to poor air quality is increasing. So it's need to monitor this air quality regular interval, as well as it's need to understand how it can be monitored by using advanced tool, so that we can collect a precise data. Now coming to the problems related to the air quality, uh, at worldwide level, we can see in India, major cities continuously they are showing that we have a poor air quality index, and it's really shameful thing for us also why it is happening. So we should understand the basic problems of the hazardous air pollutants and air quality, because nowadays the cities, especially in India, they are increasing vertically. Therefore, it is very difficult to understand what is the pollution level at different location, at different height. Second is about the encroachment of the industrial sector. Nowadays in industrial sector are coming nearer to the residential zone. Because of that, there is a chance to get exposure of such pollutants, and many locations you can see there is a sudden spike of pollutants. So it is very difficult to quantify such spike, why it is happening. That's why it is there is need to have some advanced real-time AQ monitoring systems. Now drone, coming to the drone, everywhere you can see that drone based technologies in in the market, they are dominating, especially as far as health sector is concerned. Government of India is promoting this activity for the vaccine delivery, as well as for related to organ delivery. Then transportation sector also dominating. So government of India is always positive towards this technology, because of this particular technology we can save our time. Second most important, that is the activities that needs more fuel, uh, that can be shifted to battery related vehicles, so that we can have a benefit of the environmental benefit in terms of carbon footprint generation, as well as emissions. So I will not talk more about it, that negative things about the drone, because uh, anyhow at worldwide level everybody is utilizing that, so we should tackle this problem in a smart way. Therefore, coming to the drone technology, why it is more dominating, if we consider the previous technologies, like satellite technologies or theodolite station, for the specially useful for the topographic measurement, then mapping, then 2D 3D map making, it was very costly affair. But now because of introduction of this drone technology, we can get the data up to centimeter level accuracy, and we don't have to wait that satellite will go from that particular location and then only we can get the data. Now things are changing. So drone is playing very crucial role, because we can attach the sensors, you can attach the camera, thermal camera, multispectral camera. That's why you can see in industrial sector, the infrastructure sector having maximum share as far as utilization of drone is concerned. So this technology is continuously dominating, and very important sector is hazardous areas or where there is a inaccessibility, especially in environmental domain also people are using this technology. Now, coming to the recent trend in air quality monitoring, you might have come across recent technologies that people are using the sensors with the drone at a worldwide level, and every researcher is trying to attach different air quality sensors with the drone, considering that this could save our time as well as this can give some different unique data, that is 3D data if we consider the geospatial data. So that's why lot of firms are there, especially European Union and Western world. They are coming with very good solution, that is a total solution package where they are utilizing AI also for to monitor and to predict the air quality data. However, there is another side. There are some researchers, they are attaching the sensors directly to the drone and coming with some publications. But how to attach these sensors to the drone, then what is the exact effect of temperature, humidity without considering that directly attaching? So that may create some mm, change in your reading using drone edit technology. Now, I will quickly come to the pros and cons of CAAMS. So CAAMS is continuous ambient air quality monitoring system. So NCAB is very big project, and government of India is handling that one especially for the non-attainment cities. So in India it is considered as a gold standard. So data generated through these systems. So it has many benefits because it has calibrated sensors, all the instrumentation in one single platform, and you can develop a lot of data, and it can represent the air quality of that particular location in the periphery of 3 kilometer 5 kilometer also. But it has some limitation, that is the that we cannot deny that it draws a lot of power, expensive job, and we cannot show that representative data nowadays because uh, everywhere as far as city is concerned, so instantaneous spikes are coming, especially in air pollution also. Like for example, some industry is emitting some hazardous pollutant at specific for duration of 1 hour. So if there should be some system, so it can monitor the time dependent data and spikes near to that industry. So therefore portability is issue with these camps. So, considering these drawbacks in European Union countries and Western world, they are coming with most of the mass-based sensors, electrochemical sensors, which are low-cost sensors, and portable sensor. So they are lightweight sensor, they can be calibrated, and it has very good sensitivity, but it has some drawback like they are cross-sensitive. Calibration, continuous calibration is required after some duration. Then European Union countries, they are trying to work on some co-location studies, meaning they want to introduce in future that technologies should such technologies should come in the Indian market also. So considering all these issues, we have developed our Nirikshan AQ in 2018. Considering the calibrated sensors and the drone as a vehicle, so we developed a methodology that is Nirikshan AQ, and it's a drone assisted air quality monitoring methodology where user can attach different kind of sensors and he can collect the data at different height. So so this methodology was unique in terms of the attachment of its sensors, because people were using attaching any sensors to the drone at any location, but we did rigorous work on how where to attach the sensors, and which type of sensors should be attached, and how to calibrate the data. So based on that, we got very good result, and we have demonstrated its application in many location also. And in fact, now you can see many drone aided sensor based technologies outside India also. They are also utilizing the sensor location at the top only. So basically, our job is to generate accurate data by using this Nirikshan AQ. So, this utilization of this air quality monitoring at non-accessible location. So we have developed with two different protocols. Protocol one is focusing on specifically on the surface level emission monitoring, and protocol two is focusing on like traffic intersection or industrial or sources which are in air monitoring. So we did our protocol development work specially considering these two environment. That's why air quality monitoring at non-accessible zones can be possible if you have very good calibrated sensors and as well as drone. So coming to the data acquisition and calibration part. So I will not go into detail. I will just show you the fixed wing, quadcopter and hybrid drone differences. So fixed wing drone, you can see fixed wing, it do not require any platform for launching, while quadcopter drone, it's a stationary platform. So why it is more popular, especially for the air quality monitoring? You can see if you replace this particular quadcopter camera with any sensor, you can have a stable data collection. While in fixed wing continuously move uh, in air, and it cannot be stable in air for a longer duration. That's why it is recommended that you should use quadcopter or hexacopter or octocopter kind of devices. And third is about the hybrid drones. So third, hybrid drones still they are in R&D phase. So most of the R&D application you might have come across that they are using the quadcopter for environmental monitoring. So this is a basic. I will cover trying to show you the Bernoulli's principle. So Bernoulli's principle is specifically talk about the movement of fluid in water and air. So Bernoulli's principle is applicable for the lifting of drone because of the air in air media. So you can see there is a high pressure and low pressure area concern. If if uh, mm, if particular air strike with the wings of the aeroplane, so there is a high pressure area and there is a low pressure area. So because of the continuous wind flow below that particular below the wings of the drone, it creates a high pressure area. Because of that, it lifts the drone in a vertical direction. So this principle is very important considering the downwash drag effect, or the we can call it as a drag or downwash effect, or we in a simple way we can say that because of the propeller movement, whatsoever air disturbance create below the drone, that is very important. In detail, you can see here drone is continuously moving. It is creating some sort of drag or some sort of downwash effect. So while attaching any sensor, you should be aware about that. So in CSIR-NEERI continuously we do this kind of analysis whether it is affecting the sensor or not, and based on that only we are utilizing these different sensors. So these are the sensors available in the market. So I will not go into detail, or I will not advocate any sensor that you have to use these sensors or that sensor. Only the reason behind that, while comparing the two sensors, you should have the same principle based sensor. For example, suppose you are comparing this calibration. Suppose you want to do the calibration. So suppose your gravimetric method is there. So if you try to compare with the low cost sensor, So this sensor should be a gravimetric based principle. But if it is a low cost sensor, then you have to compare that with the it is an optical sensor. So optical sensor should be compared with the optical only, not with a gravimetric. Otherwise, you will not achieve 0.99, because here you can see here in a whole day you can get a 32,000 data point. In gravimetric whole day you can get single data point. So while comparing this calibration thing, you should be very clear about the selection of sensor, and it is very very important. My colleague Dr. Roshan will discuss in the next lecture about why it is so important. He has done some collocation studies also, and these are the results regarding to the vertical profiling. So basically our drone hover at different height and we can get the data of CO2 and CO2 temperature, humidity, such kind of activity we can do. But before that, we need to carry out some calibration activities and where to attach the sensor. That is the tricky part in this particular block. Now coming to the application. Now application this particular Regression AQ has been utilized for the bird's eye view pollutant level in the industrial cluster, then traffic intersections and urban hotspot identification. Then sampling from the non-accessible or hazardous location can be possible. Apart from that, fence line monitoring at industrial site, or or that data generated using this Regression AQ you can use for the different models, air quality models. So to improve the prediction capability. Now coming to the different robotic AI assisted technique. So in future you may see this kind of application, because AI assisted drones now coming into the market, and DJI Matrix 200 series people are attaching that AI assisted instruments, and this technology is highly precise one, and it is a complete set of system. So this AI and robotic arm will play a crucial role in future also, especially for the technologies for the environmental monitoring. So most of the Western world, they are working on that in a complete package. So this technique, we cannot deny that they will not come in India and they will not create their market. So we should be ready in that direction also. How we can also attach our sensor, we can also change our sensors into smart AI based sensors. So these are the different environmental applications we are focusing. That is land use map, MSW site, mining sector, and agriculture sector. So basically, as far as environment is concerned, uh, photogrammetric is the major application where people can use multiple multispectral camera, hyperspectral camera, or RGB camera, thermal camera, and they can generate a data and for predictions. While in payload-based application, you can attach different sensors and you can use on MSW side or mining sector. So we are using such kind of activities and this kind of sensors in our R&D projects. Now coming to the need for policy reformulations. So here what I want to suggest that nowadays low cost non-calibrated sensors are coming into the market. So how to tackle that? That is a major issue. Apart from that, many government sectors also, in government sector people are using AI enabled tool, which is totally package of drone as well as AI enabled tool, and it has security issue, because while we are collecting the data of non-accessible zone, it directly it can collect some another data also. That's why Chinese drones are banned in India. So basically uh, government needs to think about that. They can use drone as a vehicle, but sensors from separate make model they can use. It means that there will not be any sharing of data between two. Then only the country like developing country like India, we can survive. Otherwise we will do some task at the same time, 10 times of the data can be fetched from that same location. So it is a really alarming situation. So that's why parameter specific monitoring option government can allow, like right now for agriculture, for some activities they are allowing, not for all Chinese drone. Similarly, for some kind of activities for air related they can allow, but not for all the activities. Second, urban planning. So drone can play a very crucial role in urban planning, especially for tracking of air pollutant in 3D space, air sampling and sensing technologies. We can connect IoT devices with the drone also, so that in future definitely whole things can be monitored by using the drone and IoT platform. So the future urban air pollution monitoring technology will provide you high level of accuracy as well as predictions. So, so that can be a very good supplement for the conventional air pollution monitoring tools, as well as that will be useful for the air pollution monitoring agency nationwide. So, this is all from my side about air quality related drone assisted air quality monitoring. So my colleague Dr. Roshan will continue about sensors, because sensors plays very crucial role while while using in a drone as well as in for urban air quality monitoring. So thank you so much.
Welcome all attendees to this NCAP training module. I am Roshan Wathore. I am a scientist in the Energy and Resource Management Division in CSIR-NEERI in Nagpur. So today's topic is on the application of low-cost sensors for smart city monitoring and how recent advances in data science and machine learning can aid in effective monitoring. First, we will look into the global and national status of air pollution and how its measurement is done. South Asia is the most polluted region in the world, and out of the 100 most polluted cities, 94 of the cities are in India, China and Pakistan. 46 of these cities are in India, and amongst the top 10 polluted cities in 2020, there are 9 Indian cities as listed here. Death rate data from the past 3 decades shows that there is a gradual increase in the deaths caused due to ambient air pollution from 1990. However, there is also a rapid decline of death attributed to household air pollution due to the shift in cooking from solid fuels such as wood, charcoal and cow dung to cleaner alternative cooking fuels such as LPG and biogas. You all must be aware of the adverse impacts of air pollution on human health. Basically, there are both short-term and long-term impacts on various organs of the human body as listed in this slide. We will now look into how air quality is measured. Conventional monitoring of air quality is done via the continuous ambient air quality monitoring stations in India. These are usually operated by the CPCB and the state pollution control boards. The advantage of these such systems is that they provide highly accurate data due to the high grade equipment which they use for monitoring. There are several challenges also associated with this type of measurement. So the operation and maintenance costs are involved are pretty high in this, and also the current distribution across India is pretty scarce. For instance, in cities like Ahmedabad and Nagpur, there is only one of these stations. Alternatively, there is a newer generation of low-cost sensors which have been developed in recent years. The advantage of these sensors is that they are able to provide a very high spatial and temporal resolutions, and they are portable, miniature, and they have lower power requirements. However, there are also challenges associated with these sensors. These sensors are susceptible to the environment, which means that their response or their readings differ with different environments such as temperature and relative humidity, and these sensors are also lower in accuracy than the traditional conventional measurements of air quality monitoring using CAAQMS. So LCS offers several advantages as discussed in the previous slide. and they can be used for very interesting applications. So here you can see the customized wireless low-cost sensor modules which have been developed in CSIR-NEERI and for real-time data acquisition. NCAP has also recognized LCS as a potential to supplement the existing air quality monitoring network, and there are also several disadvantages as discussed earlier, mainly because they are less accurate, they often drift, and they are prone to cross sensitivity and also intra-sensor variation. However, most of these disadvantages have been overcome to a significant extent by applying machine learning algorithms. Some of the potential applications using machine learning and data science has been calibration of these sensors, more specifically dynamic calibration by co-location against regulatory grade monitoring. We can also do spatio-temporal interpolation, forecasting, fault detection using machine learning, and there we can also mount these on drones, these sensors, since they are lightweight. So there are several drone assisted applications of these sensors as well, and Dr. Piyush Kokate would be doing a separate lecture on this topic specifically. Low-cost sensors are rapidly gaining popularity across the world. Purple Air is a popular PM sensor module which has been installed worldwide. They also have a website where they provide open access data of their sensors in near real time. They have a good distribution of sensors in North America and Europe. And they also have some installations in India, which is mainly in Bangalore and several parts of northern India. Let us look into the working of low-cost PM sensors. So we are focusing on PM in this lecture mostly because PM is the primary pollutant which is required to be measured under the NCAP. So all commercially available PM sensors, the low-cost PM sensors, they utilize light scattering as their primary principle of operation. So here you can see the outline of plant tower model low-cost PM sensor. Plant tower is one of the popular models being used. Even Purple Air, as we saw in the previous slide, it also uses plant tower sensors. So the sensor has a fan here, a laser here, and a sensor. So the laser is specifically red laser, and the sensor here detects the intensity of the laser. So once air with particles it flows through the cavity, there is variation in the intensity of the laser uh, because of the particles are somewhat blocking the laser pathway. So the amount of intensity decrease is proportional to the concentration of particulate matter in the air. And over here we have a fan for primarily to draw air into the measurement cavity. So I hope by now the participants have got an idea of the pros and cons of both the CAAQMS and low-cost sensors. I will now briefly introduce the basic concepts of data science and machine learning. So what is data science? There are three pillars of data science. First is the domain knowledge. The second is knowledge of mathematics or statistics, and the third is knowledge of programming. So a role of data scientist overlaps with that of a statistician, an analyst, and a data engineer. The primary role of data scientist is to analyze, process, model, interpret, and visualize extremely large amounts of data. There are 6 steps to the data science process. The first step is to frame the problem, where you need to be able to translate data questions into something actionable. The second step is collection of your data. So this is usually called as raw data. The next step is the data processing or cleaning data set. So this is probably the most time consuming step, but it is also the most important step. Here you will account for the missing values in your data set, the corrected values, if there are any invalid entries, if there is a difference in time zone, if you're comparing multiple data set, or if there is a different date format or a date range, and so on as all. Next step, once you have cleaned the data, then you are ready to explore the data, and this involves basically to look for patterns in the data. So this means that you can make graphs or make maps such as time series graphs and all. So once you have done exploratory data analysis, then the next step is to perform an in-depth analysis. This is where the knowledge of your domain knowledge and the statistical knowledge all comes into place. And then you can develop your models based on this data and how and so on. And finally, once you have developed your models and algorithms, finally you can communicate your results of this analysis, and you should be able to link this results with something actionable to get the results which you want. Let us now look into what is machine learning. So machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So what machine learning does is it focuses on the development of computer programs, and then it looks into its data set, which is you can say that is past data, look for patterns in the data, and then use what you have learned in to make better decisions in the future based on the examples which have been provided. The primary aim is to allow computers to learn automatically without human intervention or assistance, and adjust their actions accordingly. Now, the larger the data set you have, the better these algorithms generally work. And there is also a condition that the data set should be a good data set. It should not be full of errors, or it should not be faulty data set. If you have a large quantity of data and it is of good quality, then these machine learning algorithms generally work very well for such kind of data sets. Now let us see how we can combine what we have learned so far. Basically, we have learned about low-cost sensors, and we have learned about machine learning as well. So let us see how these two tools can be helpful for smart city applications, especially in the case of PM monitoring for NCAP. Let us now look into machine learning methods for calibration of low-cost PM sensors. This is primarily done in two ways. The first is an intra-device comparison, which means you check the consistency between two low-cost devices which are kept at the same location. So this is usually done to see if the sensors are reliable and repeatable as well. The second way to calibrate is by co-location against a reference grade device, which is a CPCB station or an SPCB station. And the longer duration we have for this, the better models and the better results we'll get. As we have learned previously, so there are effects of other confounding variables such as temperature and RH. Basically, changes in temperature and RH also lead to a different sensor response. So we need to include temperature and RH into our calibration models. So they are usually inputs to our calibration models as well. And then, so how do we know if a sensor, how good a sensor is agreeing to the reference grade or the device? So the common metrics usually is the R square, which is coefficient of determination. The closer it is to 1, the better the agreement is. And then we have three error-based terms, which is mean absolute error, mean absolute percentage error, and the root mean square error. So mean absolute percentage error is usually a popular metric, as it gives us the percentage error between our low-cost sensor and the reference grade device. Let us first look into how two devices behave when kept at the same location. So this was a case study which was done in Jaipur at the same location. So we have basically two low-cost PM sensors, and we make a scatter graph between the readings of these sensors. So for PM10, you can see that there is a pretty good correlation with an R square which is 0.8, which is very good, and the slope is also 1.06. Even at a very high concentrations, these sensors are agreeing pretty well. So which means that they are pretty consistent in nature. Similarly, for PM 2.5, we see that there is a pretty good agreement, and the slope is also 0.86, which is slightly less than 1, but it still can be corrected because there is a very good correlation between these sensors as well. Let us look into the calibration process of a low-cost PM sensor in Mumbai airport. So there have been three models which have been deployed to calibrate the sensor, and the performance of these three models was compared. So the first model is the multilinear regression model, which is a simple linear model. And then there is a support vector regression, which is a slightly complex model. And then we have neural network, which is an even more complex model. The model inputs chosen in this study were base features and derived features. So the base features are features which are directly captured by the sensors. So we have PM 2.5, PM10, RH, and temperature. So these features were captured by the low-cost sensor, and it was set as input parameters. In addition, there are several derived features which comes from the periodicity of the day or the diurnal variation, derived RH feature as well, time lags, and other non-linear and interaction features. And these all affect the sensor performance in some way or the other, and hence keeping these as model inputs can make our model even better. So the results of this study basically showed that the neural network performed the best, and essentially before calibration the mean absolute percentage error was 29%, and that has now significantly reduced, as you can see here. Let us now try to get an estimate of the amount of data which has to be analyzed in a day or in a year. So say there are 50 sensors deployed in a city, and they report data at every 1 minute, and parameters being recorded are PM10, PM2.5, temperature, and RH. So you get approximately 2.88 lakh data points a day just from these sensors, and if you keep them running for a year, then you get more than 1 crore data points a year. So this large volume of data, it cannot be handled by usual data analysis methods such as MS Excel. Plus there is also a need to clean the data, to remove the missing values, to figure out if any device is faulty, and so on. So smarter tools such as Python is required for data analysis, and the main objective is obviously data visualization, because that is what will help you to understand what is actually going on at various locations across the city at the same time. So in order to know what is happening at every location at a single timestamp, there is a hotspot analysis is a pretty common approach. So like for example, you can see in here Delhi. So here we have hotspots for various locations in Delhi. So some of them are less polluted and some of them are highly polluted. So this is a timestamp for one of the days in Delhi. So this is PM 2.5 and the lower one is PM 10. So all this can be automated by a code. Once you have automated this, it is very easy and very quick to generate such graphs, and it is easy to identify which areas have been polluted, or if there is an area which has been consistently showing high pollution or low pollution over a period of several days or several months as well. In the previous slide, we saw the hotspot analysis for Delhi, which was done using the CPCB stations. In this slide, we will look into hotspot analysis using low-cost sensors. So we have taken two cities, Jaipur and Ahmedabad, and you can see there are roughly 30 sensors in Jaipur and around 50 sensors in Ahmedabad, which have been installed. So this graph is of a single timestamp, and you can see that there are several locations which are color coded. So these color codes are based according to the air quality standards, the AQI category. So you can see that there are a few locations which are good and satisfactory, and whereas there are some locations which are about 300, so it is very poor. So using such graphs, you can easily identify the highly and lowly polluted locations. Coming to Ahmedabad, we can see that a lot of these places are moderate, and then there are a few hotspots around the city. One important thing to note here is that the sensor distributions. So in Ahmedabad, you can see that the sensors are quite uniformly distributed. whereas in Jaipur they are not. So if they are not equally distributed or uniformly distributed, there will be a pretty large gap of data. So for instance, in this area here, we do not have much information of what the air quality is there. Uh, So what can you do when there is a gap in data? Like for example, in the previous slide, you see that there is a big gap in Jaipur. So what can you do to fill that gap? So there are interpolation algorithms using machine learning which are available. The most popular one is the Gaussian process regression. It is also known as kriging, and it is a very popular machine learning method to interpolate across both the spatial and temporal scales. The advantage of this is that you can sort of estimate what the concentration at an area would be if you don't have air quality monitor in that area. The more equally spaced the data is, the better this algorithm works. So I'll just show you in the next slide uh, how these algorithms work for Jaipur and Ahmedabad. So in Jaipur, you can see that this algorithm of Gaussian process regression, it sort of works okayish because you see there is a big gap here, so we do not have data for these points, and then it only works well around the areas at which the sensors are located. But if you see Ahmedabad, where it has a more uniform distribution, you can clearly identify that this zone is slightly more polluted than the rest. And our reason for this might be that since because of the river flowing through Ahmedabad, so it is usually a lower lying area, so the pollution tends to settle down there. So areas around the river are slightly more polluted, and then the areas in the vicinity are less polluted. So this interpolation method provides a very good information on where the pollution, or how the pollution evolves over time in over a period of a day or month, and so on. So to conclude, low-cost PM sensors present an attractive option to supplement the existing network in India, and these can be dynamically calibrated by co-location against CPCB stations, and we can also use machine learning for various purposes, mainly calibration, interpolation, and even forecasting, of which we have not discussed, but it is also possible to forecast the next day's pollution based on past data. A network of low-cost sensors can help in collection of large amount of data at high spatial and temporal scales, and interpolation algorithms can help in that analysis by filling data gaps to some extent, provided that there is a uniform distribution of data. And then this data can be used to derive actionable insights and aid in the decision-making processes to mitigate air pollution. So finally, integration of other parameters such as satellite data and weather data can further improve these model accuracies and performance of these models. So these are some references and some reading which you can go through. Thank you very much. In case of any questions, you can contact me on my email ID.